understand perimeter for you. Okay, so the usual way for us to understand area is painting the wall. Painting the wall. So when you, let's say you want to paint a classroom. Is this classroom big? Quite big lah. Okay, one person paint now will take a long time. We say that there is a huge area for us to paint. What about your own room? Okay, your own room. Is it smaller than this classroom? Yes. Most likely, right? Your own class, did I say your own room at home? It's smaller than this classroom. It has a smaller area. This piece of paper that I have, it has a small area. The amount to paint is small compared to that huge notice board at the back. It has a huge area. Imagine if you were to paint it, the bigger the size, the more there is to paint. So the area tells us the amount of space. Okay, two-dimensional space. Then the other word that we need to know is perimeter. Perimeter is different from area in a sense that for perimeter, we go around the object. Perimeter, we go around. For example, if you ask you to run around the perimeter of the classroom, is it difficult? Run around the perimeter of the classroom, is it difficult? No, it's very short, right? You run at the edge. But if I say run around the perimeter of Woodlands, is that a lot? Yeah, that is very big already. Perimeter of Woodlands is very big. You're going to take a few hours. Okay, so perimeter deals with distance, how far it is, whereas area deals with how much space there is. That's the difference. So we're going to have different units as well. Then we try and recap some of the things that we have learned in primary school also. Oh, by the way, this is an introduction to the topic. This is actually give you some time. This is actually a floor plan. The floor plan shows how big the bedroom is, how small the toilet is, which is located next to each other, and so on. From here, we can tell the area of the house. We can tell the perimeter of each of the rooms if we need to. So perimeter, as mentioned, this is in your textbook, page 89. Perimeter has got to do with the length, and it is measured in centimeters and meters. But instead of, do we just measure length in centimeters and meters? Janice, what do you think? Any more units? Besides centimeters and meters, are there any other units that you know? What are other units? Kilometers, km. What else do you know? Millimeters, okay. Any more? Any more? M for meters. Any more? Any more? Something that Singapore actually doesn't use. Nice. Miles. Yes. Miles. Yes. Okay. Any more? Inches. Feet. Yard. Right. All these, but they are quite uncommon in Singapore. Okay. Yes. And then we have area. Area is the amount of surface covered by a figure. We think of it as like painting it. So it is commonly measured in this unit. What do you call this unit? How do you say this? The one that is circled. How do you say it? Centimeter square? We will not penalize you for wrong saying. But the correct way to say it, the correct way is actually square centimeters. We say square, then we say centimeters. Then we also, the correct way is square meters. Square meters. But normally, right, in class, we see the letter M, then we say meter. Then we see the square, right? Then we say meter square, meter square. Actually, it's the wrong way of saying it. I just need you to know this. But honestly, I don't really care what you say. As long as you write down M to the power of 2. Yeah, m to the power 2 is like your algebra, isn't it? X squared. Square meters. It's like your x squared, isn't it? Or your a square, b square. It is the same thing. What does your x square actually mean? Do you remember? Yeah, x to the power 2. What does that actually mean? Don't scare me. X. Jian, what do you think? No, not times 2. Jian, what do you think? Who knows the answer? X squared, but what is it? X times X. No, you said X plus X, then you said X times 2. So X squared is actually X times X. What about what do you think this square meter means? What times meter? M times M. Does it look funny to you? Does it look strange? No, not M and M. But why would it be the case? Why would it be M times M? Okay, so that's something that we'll find out later on also. Of course, we have square millimeters, we have square kilometers as well. If the area is very, very small, we use square millimeters. If the area is very, very big, we use square kilometers. Moving on. Okay, now we come to some formula. This is where I need all of you to pay attention. This was covered in primary school, and this serves as a recap right now. What is the area for a rectangle? Area for rectangle is asking you how much space there is over here, how much paint is required, and it depends on two things. Okay, now in your textbook, I want you to draw a small rectangle. Just randomly draw a small rectangle. This is on page 91. Okay, just randomly draw a small rectangle beside this bigger rectangle. Finish drawing? Yes, just a small rectangle beside the big rectangle in your book. Does your rectangle have 4 sides? Are the two opposite sides of the same length? Do they have 490 degrees? Okay, if your answer to the above are yes, congratulations, you have drawn a rectangle. Okay, now, is your rectangle bigger or smaller than what is printed on the book? It is smaller, right? I asked you to draw a smaller one. Therefore, your rectangle's area is smaller than the area printed on the book. But what makes your rectangle smaller? What makes you look at it and decide, my rectangle is smaller than what is printed? Is it a parameter? There are actually 2 parts to it. Not the parameter. We say the length. Your length. You see that it is shorter than the rectangle's length that is printed. It is shorter. A shorter length together with a shorter breadth will result in a smaller area compared to what is printed. 2 things that will affect the area of a rectangle: the length and the breadth. Now, I am going to draw another rectangle with the same breadth as what is printed, but now I'm going to draw a shorter length compared to what is printed. Okay, so you don't have to do this already, just watch. Same breadth, but my length is obviously shorter. Can you tell me about the area of the rectangle that I've drawn? Is it bigger, smaller, or equal to what is printed? Smaller. Why smaller? What made my rectangle have a smaller area than what is printed? We say that the length is smaller. So if the length is smaller, then my area is going to be smaller if the breadth remains the same. Now, if I were to extend my rectangle to a longer one, Now my length becomes bigger than what is printed. And that results in a bigger area. Bigger area. So two things, again, I keep emphasizing two things that will affect the area, length and breadth. If the length is longer, the area will become longer. If the breadth is longer, the area will become bigger. So then what we need to do, is simply take the length times the breadth. This is what you need to memorize. Length and breadth gives you area for a rectangle. Can memorize? Can? Can, okay. So this is called a formula. They use the letters L for length, B for breadth. L times B. Depending on the value of L, depending on the value of B, just put them in. The next part is the perimeter. I want all of you to take a pencil or pen, any other color, trace around the perimeter of the printed rectangle. Trace around. Wherever your pencil goes, you are outlining the rectangle, and that is the perimeter. Like I said, the perimeter of this classroom will be the outer edges of this classroom. If I say the perimeter of our school, well, that's quite big. You're going to run around the perimeter of the school. So everywhere the fence is, that will be the perimeter. So if I want the perimeter, I will need to add up the length and the breadth. They have two of the same length and two of the same breadth. Let's try some numbers first. If the length is 10 cm and the breadth is, for example, 4 cm, what is the total distance? The outline portion, what is the total? Is there enough information? Do we know this distance? Yes. Why do we know that? Because they're opposite and it is a rectangle. They must have the same. So this will be 10 cm. What about the other side? Yeah, so 4 cm. Total, add everything up, right? So we say that perimeter equals to, okay, watch what I'm going to do. Look. I'm not going to just simply add. I'm going to do this. 2 times of 10 plus 2 times of 4. And we get 20 plus 8, which is 28 cm. Oh, is this okay? Any questions about this? Do you think I'm actually making things more difficult than it should be? Wouldn't 10 plus 10 plus 4 plus 4 be easier? No lah, 10 plus 10 plus 4 plus 4 is easier, right? Really? Are you all rather do the multiplication? No, right? No, no. 10 plus 10 plus 4 plus 4 is easier. But what happens if they don't tell you it is 10 and 4? If they just tell you it is L, then you must know that this is also L. If this is B, then this must be B. No, it is not BB. BB means B times B. But are we doing B times B? Is it B2? So the perimeter is it L times L? Is it L times B? I'm finding perimeter. It is actually L plus B plus B, correct or not? Correct or not? I'm trying to add everything up. Any questions so far? L plus B plus B. Okay. If you take one L, you plus another L, how many L do you have? 2 L. Then you have B plus another B. How many B altogether? 2B plus 2B. Okay. So this is the formula for our perimeter. Yeah, there's some algebra, and I think we're going to test you some algebra. Okay, so same thing for the square, but this time for the square, area will be L times L, because the length and the breadth of the square is the same. So L times L, we get L squared. L squared. Does that help you understand why we say that this is called X instead of saying x to the power 2, we call it x squared. You know, at the start of the year, right? We talked about this, x squared, x squared. Nobody asked me, sure, why call x squared? Why not just say x to the power 2? Nobody asked me. Now, we look at the formula for a square, for the area of a square. When I want the area of a square, I need the side multiplied by the side. The side is called L. For a square, all the sides are the same. So I end up with L times L, which is L to the power of 2. But instead of saying L to the power of 2, shortcut, call it L squared. Does it make more sense now? Then got a question. What is this shape that I'm drawing? This is called a cube. It is called a cube, like when you play board games, there's dice, right? So the dice, that is a cube. I do not know if you have learned volume in primary school. If this is L, this is L, and this is L, what is the volume? L cube, yeah. Length times breadth times height, right? L cube. Now, do you know why we call this power 3? Instead of saying L to the power 3, do you know why we call it L cube? Because it's a cube, yeah. The volume of this is a L cube. So we use that. Okay, now back to the square. Perimeter of square, there are 4 sides. Each of them will be L, L plus L plus L plus L. How many L altogether? 4L. So the perimeter is just 4L. Now, work example number 1. No need to do, they have already done it for you. Find the area and perimeter of this rectangle. So area is just 125 times 80. Get the answer as 10,000. But what are the units? You need to state the units. So 125 times 80, yeah, we get 10,000 as the number, but the unit will be, look, you have cm times cm, right? So if you have x times x, you get x squared. You have a times a, you get a squared. You have cm times cm, you get square cm. Okay, or cm to the power of 2, cm squared, okay, whatever. But basically, you write cm squared. Okay, so that is how we use the units of the length to help us decide what is the unit for the area. The next one, we have the perimeter. Perimeter will be 125 plus 125 plus 80 plus 80. I'm just going to copy the answer. So we get 410 cm. So that's for the area and perimeter of the rectangle. Like I said, you don't have to copy this down because it is already printed for you. But what I need you to try is the next one. Try it one. Find the area and perimeter of the rectangle and the square. Who has already finished? Raise your hand. Nobody? Okay, all do now. Area for the rectangle. First, find the area. So you have to write down area equals to. Did you write that? Area equals to. If you didn't, then I'll be wondering, hey, is he finding area or perimeter? If I have to guess, I will surely guess wrongly. 40 times 60. So you get 2400 square meters. Perimeter will be 40 plus 40 plus 60 plus 60. So that gives us 200 meters. For the square, area will be 50 times 50. 2500 square meters. Whereas for the perimeter, we have 4 times of 50, which gives us 200 meters as well. So notice in these two examples, they have the same perimeter. Same perimeter, but the areas are different. Which means that if you are given a piece of string, a fixed length of a string, you can construct a square and it has an area. You can use the same string to construct a rectangle with a different area. So this over here, workbook exercise 9A, question 1 to 3, that is your homework. Okay, please note that down. Over here, your workbook, exercise 9A, question 1 to 3, homework due 28, which is tomorrow.